مرحبا دكتور.
السلام عليكم.
وعليكم السلام. السلام عليكم جميعا. اليوم في أول حصة الجي تك حول جوجل كلاود مع دكتور نبيل اللي هو جوجل اكسبرت. So, Doctor, can you start now?
Thank you.
Thank you so much.
Assalamu alaikum. Good evening, everyone. Thank you for the invite from the team. Well done. It's really a pleasure to be with you today. Let me see. Can you see my screen? I'm sharing my screen. I don't know if you can see it. Right. Okay. Right. My name is Nabil. I'm a Google Cloud trainer with a company called Jellyfish. I'm also a Cloud GD here in the UAE. Today we're going to cover introduction to Google Cloud to see what this technology is going to give us at a top level. So we will have two sessions. Today is going to be introduction about the topic itself. Tomorrow, inshallah, we will be doing some labs through the platform. I don't know if you've heard of it, Quick Labs, through this program called a Study Jam, which is a set of labs that we introduce. We give you the platform to practice, to basically get your hands dirty with Google Cloud. So without further ado, let me start talking about the Google Cloud. But before we talk about Google Cloud itself, what I want to do is and talk about what is to start with. What is cloud computing to start with? So let's have a look and see what it means to use cloud, public cloud, that is. So if you've been using servers on premises or on in your bedroom, you might have a server that you are using, or even your laptop is another compute option for you to run programs, to do computational operations, to store data, all those kind of stuff. Cloud is very different than that. So when we look into that, we look what it means to have these different, what we call service models in the cloud, because there is a lot of misconception about when we talk about the cloud. People think that there is something abstraction, that there is nothing behind it. There is no hardware, there is no networks, there is nothing. The fact is, cloud is just an abstraction layer that sits on the top of a big infrastructure for different cloud providers. So what are some of the common cloud terminology that we're going to be talking about? We're gonna mention things like these kind of buzzwords that you probably heard here and there: elasticity, fault tolerance, and also from business sense, what does it mean to be using cloud? What advantages are we having using the cloud? So you probably heard of things like OPEX and CAPEX, so capital expenditure, operational expenditure for OPEX. So when we talk about cloud, those kind of 5 pillars, there are 5 attributes that was kind of a definition by the National Institute of Standards in the US. That they said there are these kind of 5 characteristics for any public cloud provider they need to satisfy in order to have to be able to provide public cloud service. So the first thing cloud needs to have is this concept of on-demand service. So you should be able to provision those computing capabilities, whatever that might be, storage, compute, memory, network, servers in the cloud. So you will be able to provision those capabilities as needed without needing this interaction with somebody, without this requiring this human interaction with, let's say, a third-party service provider or if you are working for a company, it's going to be something like a help desk. So you're probably going to send an email to your help desk, or walk into the help desk and ask them, for example, for I need a server, I need a virtual machine to work on because I want to deploy this code, I want to run this application, I need a VM, which takes usually a couple of days for IT department to provision that for you. They've got a process to follow. They have SLA to adhere to. So and usually you will find that between 24, 48 hours, depending on the company what you work on. So cloud is completely different. Cloud is on-demand self-service. So you have no interaction with someone. You will be interacting with something else, which brings us to second point. So cloud service is should be available wherever you are. So you should be able through a broad network access using a standard mechanism, which is like a Chrome browser or any browser that you have. So we're talking about web standards in this case. So those kind of 1 and 2, these 2 points work hand in hand. So you should be able to provision those without interaction with someone, and you should be able to access and provision those resources whether you are on your desk at work, or you are at home, or you are at the university. As long as you've got that device to access the internet, you'll be able to go to let's say a web console to access the front end, the UI that the cloud provider has given you in order to provision those resources. And then thirdly, what you will find in any cloud provider environment, actually you will see those 2 points, resource pooling and rapid elasticity. Obviously, when you are a public provider like Google Cloud or AWS or Azure, those like big companies, what you will find, they will buying in bulk. They will buying thousands, if millions of servers. They would be having data centers across the globe in different regions across the globe. So they will put all those resources they bought in bulk. They would put them in what we call a pool, and this pool of resources will be shared with these customers who are going to be the customers of this cloud provider. And this is what we call multi-tenant environment model. So this is what multi-tenant is. So the multi-tenant, basically multi-customers tapping into those in that pool of resources, and they will be sharing those resources. So if I need today, I need 100 virtual machine, I will be able to provision that from that pool. If tomorrow I need just 50, I can basically put back those 50 back. So this is what we call the pooling of resource sharing. Obviously, there is security mechanisms in place to make sure that nobody's accessing other people's data or compute resources. And then point 4, rapid elasticity. So you will be able, this pool of resources, it needs to be very, very efficient. It needs to be very, very fast. If somebody requires those resources, the pool is available for them. They can provision them very, very quickly. And in the other hand, they should be very efficient in the way of scaling down. So if I don't need those resources anymore after 3 days, 1 month, 3 months, whatever that might be, I should be able just to shut them down. And what that means, they get given back or taken back to the pool of resources. So this kind of 3 or 4, those 2 points, they kind of work hand in hand. They kind of tie together. And also this buying in bulk, what it means from the advantages that you get is when any company buys in bulk, whether in cloud or anything else, they buy cheap. Which means that the customers they're serving, they would be passing a lot of discount for them. And this is why in the cloud environment, there is no capital expenditure. So any provider, when you are in the cloud, you're not spending any money up front. When you need the resources, you pay for them. It's like you're renting resources. When you don't need them, you put them back and you pay for them just when we need them. And then finally, point number 5, those services can be monitored, they can be controlled, you report them. So basically, they provide you with this transparency into what they're using. So you will have logging and monitoring with them. So you will be able to see who's accessing what. You will be able to see um, who provisioned something, who hasn't provisioned something. So you got complete visibility into your consumption of those resources, and also you will have logging and monitoring to tell you if there is any issues, and also it gives you visibility into what you are using and what you are paying for. So this is kind of the five kind of pillars or attributes any cloud provider should have, and this is what's basically the cloud, the public cloud is. But before we get to into further details into that, first of all, how did we get here? Where were we, and how did we get to the point what we are in the cloud? So what you see on the left in here, those resources that are in red, that's what we call physical physical infrastructure that was hosted in real data centers. This is what it started. So big company, big enterprises, what they started at the beginning, they were building these big data centers. This is where they host their infrastructure, and then they move, or basically, or they, if they are not the enterprise level, maybe they are medium-sized companies. You will find them using these local computer rooms where they have the networking gear in there, they have the servers and things like that. And then the concept of co-location facilities came into play. So instead of companies building big data centers, so they have to invest a lot in building these data centers. What they were using what we call co-location facilities. So co-location facilities, they are still data centers. They are at a larger scale, but they are shared facilities. So any company can come and say, okay, I want just this much of space to host my IT infrastructure, and then these facilities, they would be provisioned with the cooling, with the networking facilities, with the internet capabilities, and all the rest of it. So they are ready to just plug in your IT infrastructure in there, and you will have basically a space to host your resources. And this gave a lot of efficiency to companies in terms of expenditure, in terms of capital that they were, for example, they were spending a lot of money. They were investing in building data centers. Now they are kind of with colocation facilities. They don't have a capital to invest at the beginning, so they are renting this space, and that capital they invest in the technology. So that gives them kind of more flexibility into investing in the technology and moving forward with innovation ideas and things like that, cutting edge technology and things. And then came in the beginnings of 2000, we've seen the virtualization. So the virtualization came into existence, which gave IT companies more efficiency into agility and deploying application and services very, very quickly. So before, when you wanted to deploy a new application, you have to order a server, which takes a long, long time. So you have to have a purchase order, you have to send it to the company, you need to do capacity planning, which means that I need to have an idea how much this application will need into resources, and I will that measurement will help me to size exactly the server that I need, send it to something like HP or Dell, and they will be weeks later, they will be sending the server. You need to take it to the data center, you need to put it in the you need to rack it into a cabinet, and you do all the cabling, the networking, and the rest of it before you can even get to install an operating system and an application. So that process now with virtualization, I can create a VM in few minutes. I'll be having my virtual machine ready. So the component of a virtualized data center that you see here in green, they basically the same as what we have in the physical data centers. You still have the disks, you still have the servers, you still have memory and CPU and all that kind of stuff. But now they are separately manageable from the underlying hardware. So you manage kind of an abstraction layer kind of the virtualization layer of all those kind of things. So this virtualization technology allowed companies to use resources more efficiently. They gives them more flexibility and agility compared to the co-location and physical data centers. So it became a lot more flexible. But with virtualization, even at that, there is still kind of the underlying infrastructure that you need to think about. So you will still have to buy hardware. You still have to maintain the infrastructure. You will still have to look out for security, the patching, for the underlying infrastructure and things. And on top of that, you will need to have a look and maintain the virtualization layer on top of that as well. So you will still in the business of, for example, guessing how much hardware do I need in the next 6 months, in the next year, in the next 3 years, whatever that might be. So you still managing infrastructure as such. And then one of the trends that we see today is cloud. So moving into this model of serverless service, into fully automated service. So as an example, if I'm using, let's say, a SQL database, an SQL database, now a lot of cloud providers, they provide you what is called a managed service, which means I don't have to install a service, I don't have to install a database, I don't have to worry about the server where my database is. They will give you what we call a managed service. So you probably go to some kind of a web console, and you will see, for example, in Google Cloud, you will see a service called Cloud SQL. And with Cloud SQL, you basically say, okay, where do you want this SQL to be installed? So you specify what region of the world you want to install. You specify, for example, how much memory and CPU. You will specify how much storage you want and things like that. And you just specify those, and the service will be created for you. It will be managed for you afterwards, so you don't have to worry about security, patching, installation, and those kind of upgrades, replication, backups, all those kind of stuff. They would be taken care for you by the cloud provider, and in our case, this is what Google Cloud will be doing for you. So you don't have to worry about the security of the disk and the encryption, the communication between services. Everything is taken care for you by Google Cloud in that case. So that kind of direction that came from how did we get to be using the cloud. And talking about databases and data and things, this is where speaking about data and databases, and one of the things that Google are really is about is when you start thinking about the public cloud, is every company is a data company. Whether you are small, whether you are medium size or enterprise level, you will have data that is the core of your business. Either it's your data that you are managing or data about your customers. And one of the things that really has made Google Cloud very popular and very kind of powerful and strong in the market is the tools they give us to manage data at scale. So it provides you with analytics capabilities. It provides you with predictive power to get insights from your data at scale with machine learning and artificial intelligence. So you might have like a lot of data about your customers. You could use that data to build a better application, to build a better product, and do kind of really insightful analytics, which is like being has been a big part of Google, and Google now in Google Cloud has been like they provide you with a very wide kind of range and a variety of services for managing data and getting value from data at scale. When we say scale, I'm not talking gigabytes here. We're talking terabytes, petabyte, exabyte scale with these tools. So this is the architectures that we have on GCP, the computing. So where can I deploy my code? What are the services I can use? There's a kind of very wide range of services. So if you are used to managing your application yourself, so you get server and you install your application and manage it yourself from end to end, this is where you get things like compute engine. So compute engine is infrastructure as a service. So basically it's VMs, virtual machines in the cloud. So Google will give you that service. You can select a very wide range of the VM types. You can customize them, and you install your application and manage it yourself. And on the very end of the spectrum, you will see completely serverless services. So when I say serverless services, means that I don't see any hardware. I don't access any underlying infrastructure. So I do get service. And this is where we see like machine learning APIs and a platform to do data science, platform to do our machine learning algorithms, or do data analytics at scale, like things like BigQuery, or doing things like data manipulation and data pipelines with tools like data flow, like data fusion. These are of the products that are exist on GCP. And in the middle, things for developers. So if I want to deploy my code, this is not about data. I want to run an application. So you've got what we call in the middle platform as a service. So this is what the developers, they like. Developers, on the people who writes code, what they hate to do is to manage a service, to install the hard drive, to do encryption, to install an operating system. Usually what a developer or somebody who's writing code, they just want to write code, whether it's Python or Java, and just like give it to someone to install it for them on a piece of hardware on a server, and they want just to do that application running. App Engine gives you just that. So it's a platform as a service. It's done for developers in mind, so they can deploy the code, and the infrastructure underneath is fully managed by Google for them. And then you've got things like serverless logic. You've got like cloud functions, this kind of stuff that I call it function as a service. So sometimes you don't need an application to run 24 hours. Sometimes you want just to do a task, a function to run at a particular moment of time that is triggered by an event. So let's say you have some IoT devices, you're picking up some pictures that you want to maybe do some manipulations on them. So when you store them on, let's say on storage, you want just to be notified when a picture has been picked up from an IoT device. You want to trigger a function to do something. So this is kind of thing what cloud functions are there. And then Kubernetes, this is another compute. So if you are doing containers, if you're running an application in containers, if you're using, obviously you need an orchestration, which is Kubernetes. Now on premises, you can install a Kubernetes cluster end to end. Google are giving us a managed service for that. So you don't have to install Kubernetes. Kubernetes already for you. So you can deploy your containers into the cluster, create cluster very, very quickly, let Google manage it for you, and deploy those containers into the cluster. And here, when we talk about the big picture, the where Google Cloud exists in the globe, it's one of the biggest differentiator about the Google Cloud compared to definitely on-premises or other cloud providers is the network. So network plays a big part in Google Cloud. Without kind of bias or anything, I can put it simply that Google has one of the most powerful and robust networking infrastructure on the entire planet. There's more than 40% of the internet traffic goes over that network on a daily basis. It is one of the largest, if not the largest network of its kind. And Google have invested billions and billions of dollars over the years, and they keep investing, they keep linking like regions together across the globe. And if you think about it, why do Google have invested in that much money? Because they run applications like YouTube, like Gmail, like Google Maps, like Chrome, like Google Photos, and these applications, they are 1 billion users each running. So in order to serve those kind of numbers at scale for this application, 8 applications, actually YouTube has got 2 billion active users. The network has to be really, really powerful. And this is what Google has provided that network to serve this kind of very powerful application. So the very same network that drives those 1 billion plus users applications is the same network that we're going to use for Google Cloud. So Google Cloud sits on the same infrastructure, and it has other things like what we call edge point of presence. It's got what we call let me think, the caching points, so CDNs, content delivery network, where you get cached content across the globe. So this is why, for example, in if we think about, for example, YouTube, for example, you will never see latency or a video buffering or anything like that. Very, very rare you see that. And this is because of this caching concept. So if somebody is in, let me probably bring down the Google Cloud locations. Let me see if I can bring this to the screen. See, can we see that? Okay, 1 second. Yeah, maybe it's better to share this like this. Yeah, I'm trying to share. Okay, it's there. So this is the cloud location. So I'll probably share this in. Yeah, this is the link. So here, what you see is what we call regions and zones and network edge locations. So if I go to the network itself, so what you see here is, let me bring that a little bit. Okay. So any blue dots that you see here is what we call regions. A region is basically a city across the globe that has. Sorry, I think my 1 second. I need to plug in my my charger. Sorry about that. Okay. All right, we're good. I don't want to. My laptop dying on me in the middle of the session. Yeah, I was saying. So you see here the blue dots. This is cities across the globe where Google have data centers. So this is what we call regions. So a region is could be a city in India or in there's a lot in Europe, lots of in the not US. Two regions in Australia. Singapore and Jakarta. So these are the regions that are the white ones is what is coming up in the future. So Google had, I think in the last for 3 months maybe, you see here there was 28. There was actually 24. So 4 regions in a space of 3 months. And when we say 2, 3, those 3 or 4 regions means big kind of investment. So those regions will have, each one will have 3 data centers, and all these data centers will be linked together with the fiber network. So the network looks like this. So this is the Google network. So this kind of subsea cables, on-land cables, fiber optics basically, and Google, they own this network, so it's their own. Actually, a few years ago they bought a shipping company that does the shipping, that does actually the subsea cables for them. They've got all the technology to do that. So, and they keep investing, they keep linking. For example, here this is Grace Hopper 2022, linking the North America to UK, and Spain, and then this is coming up to link Europe to Africa as well. So here, what we see here is what we call the edge point of presence. So this is in Africa, where probably there is some edge point of presence, meaning that there isn't data centers here, but if people want to use Google Cloud, basically they will be having capabilities to link to the Google network very quickly. So they will be coming from their ISP, their internet provider, into the Google network, into these points, in order to be very quick and leveraging capabilities of Google Cloud. The other thing, you have CDN, point of presence. This is content delivery network. So this is what Google, they use for YouTube, for example. So YouTube, by the way, as a side note, YouTube, it wasn't started by Google. YouTube is a company that Google bought back in 2006. something like that. They bought it for 1.65 billion at that time. It was surprising to the market that Google have put so much money into a video kind of storage company like YouTube. Now, obviously, they added a lot of capabilities to it, like what we are seeing here with advertising and machine learning and all those capabilities. Now, Google, they are making, as of the last updates into their figures, they're making $1.65 billion every 3 weeks from that. So imagine the investment they put in. Now they're making that much money in every 3 weeks, which is massive kind of profit. CDN, like I said, they use it for YouTube. So the way they use it, let's say you've got somebody here at the far end of the US, and they uploaded a video. What's going to happen? So if I change this point here, I will see these caching points here. So what happens in there is this video will be cached in all those locations across the globe. And so if somebody, let's say in Australia, wants to watch that video, he's not going to stream it from this point here where it was uploaded. He's going to stream it from this caching location next to them. So, and this is the beauty of that CDN. And it is available, the same service available on Google Cloud. So you can use it for your own applications. So if you are serving static content, it doesn't have to be videos only. You can have like big files that you share across the globe for users, photos, whatever that might be. Cloud CDN is a good option. So these are like the regions and zones. And like I said, regions are kind of locations where we've got these data centers. So and in Google Cloud, what you have is the services then they are created in those zones and regions. So a region, like I said, it consists of 3 zones. This is Europe West 2. I think this is UK, if I'm not mistaken. Yes, I think it's UK. So 3 data centers. And then when you create Google Cloud resources, they could be created in one zone, which we call them zonal resources. So like a VM, it does have to exist in one data center. And then you've got regional resources. It could be like a cloud storage bucket. So cloud storage that could be exist in one region, which means it will be replicated across 3 data centers. Or you have multi-regional storage buckets, which basically replicated across multiple regions that we've seen in that map. And you have resources that are very, very global, like the network itself is global, the load balancers, and many, many resources that have got a global scope. So many services in Google Cloud, they've got different scope, zone, region, multi-region, or global scope. So this is what a region looks like. So here what we see Europe West 4, which is the Netherlands. This is, I think, came back 2019, 18, 19, something like that. It was 1.2 billion euros, something like that, 1.4 billion euros to build this region. So you see here 3 data centers. So you see here 3 Europe West 4, A, B, and C, and they're completely segregated in terms of power, in terms of networking, in terms of cooling. So all those capabilities, they are segregated. So if one data center goes down, it doesn't affect the other data center here. So this is kind of a design that Google have put in. Usually if you, it's not common now in Algeria. We don't have too many data centers, but usually when you are a big company, you have a data center. This is what we call high availability. So you need to have another data center that is further away from the first data center. So if you have a disaster kind of happening, natural disaster or something like that, then you can fail over, meaning that your resources, your application is replicated in another region, and you can still basically your business still running. So you're not losing your data, you're not losing your capabilities to be operational as a business. Now, Google have put in this design where like data centers are very, very close together. And the reason behind it is the network is so powerful. So they put this design for, in this case, then if you have like logical DR. So if you have, if you lost like one VM in here, you can fail over very, very quickly here. But the question that comes in mind here is, what if I have a natural disaster? Let's say this city in the Netherlands, and we have, let's say we have an earthquake, for example, God forbid. So most likely you're going to lose all the 3 data centers in this case. And even if you have 2 data centers in at the end of the city, maybe they are 30, let's say 60, 70 kilometers aside. If you have a powerful natural disaster like an earthquake, you're most probably going to lose both data centers. So Google, what they've done these regions, a set of kind of campuses with like multi-data center buildings in different regions. So I can basically, because the network is so capable, I can fail over complete region. So let me show you here an example. So if I bring in our first, if we look at the console, so this is the Google Cloud Console that hopefully you'll be working on tomorrow in our practical labs. So here, if I go to compute engine, which is the instances, I'm going to create VMs here. So what I'm going to be doing here, or actually I've got, oh, let me create those quickly. Let me delete those. Oh no. Okay, let me just create a couple. Quickly 2 VMs. And this is what I said, demo 03. This is what I've got like regions. So we've got 28 regions across the globe. So they are divided into America, Europe, Asia Pacific. So I can go to that, the one that we've just seen. So the Netherlands, Europe West 4. I can create a VM here, put it in a network. Let me select a network here. And this is why I say you don't have to interact with somebody to create a VM for you. You can do it yourself from this console. And this is the beauty about public cloud, and Google Cloud is no different than that. And this is how quickly you can create a VM. So if I create a second VM, and I'm going to create it in a completely different country. Demo 04, and I'll go for, let's say Belgium in this case. So I've got 3 data centers. I'll create it in one of those data centers. And I'm going to put it on the same network. Which is this one here. I'm done. Create. If you notice here, my other VM is already done. So demo 03. So I'm going to SSH to this, like logging to it. So in less than 1 minute, I would say, I'm creating 2 virtual machines with all the networking, the storage and everything. I'm able to log into them. So I can install applications on them very, very quickly. Even virtualization, I won't be able to do it this quick. If I was just have access to VMs, I won't be able to do it that quick. Let me make this kind of bigger. So I've got this demo 03. I created it in the Netherlands. I'm going to ping that other one, demo 04, which is in Belgium. And if you look at the latency, 7.1, 7.0 milliseconds. These are two VMs, notice, two different countries. Some people, they don't even get this latency in the same data center, let alone in the same city. So this is how powerful is that network. So I'm able to, if my city has been hit with a natural disaster, I can fail over to a completely different country with my resources in under 7 milliseconds. This is how quick is, how powerful is that network that Google are using on Google Cloud. So moving on. So this is like the data center, the regions and zones. While I create that, the network that sits on the top of that. And this is what we've seen in the regions and zones. So this keeps growing. We have 28 regions now, with 3 data centers each. Obviously, we're not seeing anything in Africa yet in here. So there is a lot of happening in the Middle East. So there is Qatar and Saudi Arabia coming straight after that. So there is a lot of activity happening in that region, in India as well. But hopefully we will see something in North Africa in the next few years, which will basically make a big difference in the region as well in terms of jobs and technology and all that. Also, Google are very, very committed to environment kind of responsibility. They've pretty much been like that since 2007. They've been 100% kind of carbon neutral since that 2007. And if you think about it, I think pre-COVID, Google have invested. That's the one that we've seen, the one in Netherlands. This is one of the data centers they spend, like I said, 1.2 or 1.3 billion euros on them. There are other regions they invested in, so they invested like 10 billion in the US, another 3 billion in Europe, and so on and so forth. So the amount of service they have across the globe, we're talking about, I've seen some figures maybe from 3 years ago, or even more, 5 years ago, they were using in excess of 3 million servers worldwide. So you will see, using that kind of number of servers globally, you will need to have a tremendous amount of energy. And like I said, Google has made consistent commitment to this. First of all, 100% renewable energy. I don't know if you've noticed, if I go back to that data center here, look here, they use wind, they use this sea kind of water to generate electricity. So it's always renewable energy that they rely on. And they basically build their own service for energy to be energy efficient, and so on and so forth. So they are committed to that, and they achieved this ISO 14001 certification for carbon neutral for all the data centers across the globe. And also from pricing perspective, they are very, very competitive. They are the first company to provide this kind of per second billing. So when you use a VM, for example, when you start a VM, they will charge you per second. So you will see incremental of after the first minutes, after the first 30 seconds, you will start seeing your bill incremented per second. Many discounts. So if you leave a VM running for the whole month, by the end of the month, you get over 25% discount. If you enter in the contract with Google for 1 year or 3 years, there is corresponding discounts for that, for long-term contracts. Preemptible VMs, there is some special service in Google Cloud that you can use, and they give you 80% discount, but they don't run over 24 hours. They don't have SLAs, service level agreement, so they're not guaranteed. So usually they are good for computation that you do for a couple of hours or 3 hours. So it's not for like a production day application that runs 24 hours a day. And then you get many other things. You can get custom VMs, which means you can specify exactly how many CPU, how many memory that you want to exist on a virtual machine. We're gonna see that tomorrow in the labs. But also you get something that they leverage here. So you can see here, if you see in in this recommendation. So let me maybe make this a little bit bigger. So this, yeah, maybe, yeah, what you see here, this recommendation, this is what we call the recommendation engine. So when you run a virtual machine on Google Cloud, after 24 hours, there are machine learning models, programs that run in the back end that will check your workload. So if you are running an application or some computation on that, and you are using more CPUs than what is required, you will get this recommendation. You will say, okay, you can save $13 a month if you downgrade this machine. It will tell you, for example, here, actually you are using this demo 01 in Europe West 4. We recommend shutting it down. So basically, I haven't been using this virtual machine at all. So it tells me you're better if you shut it down because you're not using it at all. Basically, this is what we're saying. The other one here, let me check this one, $26. Again, they're asking me to shut it down so I can basically save money. But usually what you get in this case, because I haven't been running anything, this is a good one. So here, for example, I've been using 2 vCPUs, 4 GB of memory. I was running some kind of workload on this virtual machine. After, I don't know, 3 days or something, it's telling me actually what you are using is too much for this workload that you are running. You can save $12 per month if you downgrade this machine to 2 vCPUs and 2 gigabyte RAM instead of 4 gigabyte of RAM. So I can just say, yes, apply that, and it would reconfigure this machine for me. So this is the kind of things that Google will help you to minimize the cost. So this kind of very useful as well. And also Google are known to be always advocates of open source. So a lot of technologies that you hear of these days, they are kind of Google. They've started technology. So we're talking about things like Kubernetes. Kubernetes is technology that is open source, that Google have started it and they make it available to the community. TensorFlow is another one that is open source. It's started by Google and they make it available for community. And there is like Apache HBase, there is Hadoop, all those technologies that Google have started and made them open source, and they created a managed service for them in Google Cloud. So Bigtable is based on HBase open source framework. Cloud Data Proc is based on Hadoop, which is another kind of open source technology that Google have started. And then you can integrate with multi vendor technologies with their own products. So they got logging and monitoring, for example. We have what we call Cloud Operation Suite, which was called Stackdriver. You can monitor and do logging for your on-premises VMs and applications, and on other cloud providers like AWS as well. And Kubernetes, obviously, because it's open source, you can use it on. You can use Kubernetes on premises or on any cloud provider as well. And security also. Security, Google are known for kind of very kind of particular about security. So we say like security is the DNA of Google Cloud. So whenever they design a new service, they start thinking about security at first, and then talking about the capabilities of the service. So there's a lot of layers of security in Google Cloud, from the hardware itself, from the building themselves. They got encryption between services in Google Cloud. Always between communication is always encrypted. Data is always encrypted on the storage. Any storage in GCP and Google Cloud is encrypted. And then you've got at the edge of the network, there's a lot of services, and Google they think about the denial of service protection and DDoS attacks, those kind of taken care of. And they've got intrusion detection for the hardware, for the building themselves, for the data centers themselves. All their users, they use what is called the UTF, the Central Identity Service, with support for the UTF, two-factor authentication. all the employees use that. The data centers, not every employee of Google can access the data set. Only few, but they've got access to that data set. So they do take security very seriously at the level, and they give like best practices for their customers to follow those best practices and give them the tools to implement security at depth when they implement their solution on Google Cloud. So we've seen kind of at a high level what is the Google Cloud, how powerful it is, and things like that. So if you want to build like a robust solution, Google Cloud Network, it's the Google Cloud is platform is global. It's very cost effective. It's open source friendly, designed for security. So if your goal is to build this reliable and scalable security infrastructure, you can use Google Cloud for that, and it's very competitive, and it gives you a lot of kind of options when it comes to computing and computing resources and computing capabilities, storage, big data and machine learning, application services for web, for mobile, for analytics, and a lot of options for back-end solutions. And this kind of the services that are available in GCP. So you've got Compute Engine, which is VMs, Kubernetes Engine, which is virtual machines, Kubernetes clusters. Kubernetes Engine is a Kubernetes cluster managed service. App Engine, I briefly talked about that. It's a platform as a service where developers can deploy their code, and then Google Cloud will manage the infrastructure for them in terms of patching, scaling. So they just need to code and let the service manage it for them. They don't need to install the code on a virtual machine or anything. They just need the IP address of their application to give to their users to use. And then Cloud Functions, which is an event-driven service, function as a service, like I said. And then from storage, there are a very wide range of storage services. You've got cloud storage for blob when you want to store your videos or backups or archives. And then you've got a very wide range of relational databases, non-relational databases like SQL, NoSQL. So in this case, you've got Cloud SQL, Cloud Spanner. We've got a document database like Data Store, which is similar to MongoDB, if you've heard about that. Bigtable, another like a big database that is used for collecting data at scale from at a very high rate from multiple locations. And then for big data, there is a wide range of services to deal with that. So you've got managed Hadoop, you've got data flow for data transformations, you've got PubSub messaging system to collect messages and basically manage that, to do publisher subscriber model in there. BigQuery, another powerful service in GCP that gives you a data warehouse that is managed completely for you. And then you've got Data Lab for data scientists, and then machine learning as well, very wide range for pre-trained models. So you don't have to be a machine learning engineer to be able to start using machine learning models and things. But it gives you also what we call the AI platform, where you can start from scratch. So if you are a machine learning engineer and you want to start your own models end to end, then you've got the platform to do that as well. So that platform is also managed for you. You just focus on machine learning models for yourself. So this is like a very kind of big overview of Google Cloud. I've showed you a little bit about the console, where we've seen the VMs, talked a little bit about the network and the infrastructure, and those kind of 20 or so services at a high level. Our session tomorrow is going to be what we call study jams. So study jams, what they are kind of a community learning program that we're going to take some of the learnings that we've done today and get you to access the web console and do some kind of labs. So what we're going to do, we're going to give you access to 1 full month So those labs, they come into different areas. So tomorrow we're going to start something like at the basic level. We're going to start deploying some kind of services on Google Cloud with maybe something like GCP Essentials. And then hopefully in the future, if we have more sessions, this is the idea. I mean, I do run these activities in other GDG groups, and what we have like 2 sessions a month where we introduce a topic in one kind of session like today, and then we give a study jam access for the full month for a set of labs. So you get, in each track, you will get a set of labs that you're going to do. They give you the tasks, that the steps, how to perform that. They are very, very well documented. And then at the end of each one, they give you a challenge lab, which means after you finish those labs, they will in the labs that you're going to do, they will tell you what to do, the task, and then at the end they give you a challenge and they say, okay, we want to create this solution, and they don't give you basically the steps. And when you achieve that, you will get what you call the skill badge. Skill badge is something that is recognized by Google, that you can put on your CV, that you've got the skills in that particular area of Google Cloud. Very, 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 very useful to first of all to learn, and second to build your skills and give value to your profile when you're applying for jobs as well. So there are different tracks. There are infrastructure. There is something for security, Kubernetes. There is something for machine learning, image processing. There is TensorFlow. There is BigQuery, so data analytics. There is a kind of a wide range in there of those study jams. And yeah, so our first one is going to be tomorrow. So we'll provide you with the links and things through the team. So this is what I've got for you today. If there is any questions, please put them across now. I'm happy to answer them, whether in English, Arabic, or whatever.
Thank you so much, Doctor. Actually, we talked about a quick labs, so everything is clear. There's some questions here. Okay.
Okay.
Okay. Can you see them on the screen?
Yeah, I can see. What is security aspects cloud offers? That's the first one. Okay, yes. There is a big misconception about security in the cloud. People, when you say cloud, the first thing that come up, they will say cloud is not secure. It's completely the opposite. I mean, for a company like Google or AWS or Azure, these companies, they spend billions of dollars into building those data centers, make those applications secure, and so on and so forth. But security is always shared between the public provider, the Google provider, the cloud provider, and the user itself. Now, if, for example, let's say Azure or AWS or Google, they've given you this service to create storage, and they give you the tool, and they will tell you, this is how you secure it. Use this tool to secure it. So it's not the cloud provider fault that you probably didn't create a password so everybody can access, or you made your data public, for example. So not just Google, but anybody, any cloud provider, they give you the tools to secure those services, and it's up to you then to secure them. They're not going to secure them for you. So if you are putting some files that are very, very kind of sensitive and give public access to them, that's not the cloud provider fault in this case. It's you that you haven't used the tools, you haven't basically learned the security aspect of that particular service in that cloud provider. So from security perspective, like I said, it's always a shared responsibility. So if we take, for example, VMs, there is a lot of responsibility lays. Obviously, you will have the hardware itself, you will have the data center. That's all the responsibility of Google. And then anything on top of the virtual machine, when you create it, it's your responsibility. Patching, creating, installing the operating system, patching the operating system, being able to decide who have access to that, being able to say, okay, I want a public IP address on my VM or not. the firewalls that I'm going to put to protect my VM. This is all the responsibility of the customer. So they give you the tools, and you will do that. What are the advantages of using cloud computing? Yes, very, very good question. So there are many, many advantages. So one of the things that advantages of as, for example, as maybe you are students, you are doing projects, you're doing some research, and you need a powerful virtual machine to create. Now, if you go to buy that yourself, there is a lot of investment that you're going to put in place for something, maybe a project that you're going to work for 2 weeks, and then you will not use that virtual machine. Cloud gives you capability to create a virtual machine to do whatever task you want to do with it, and then when you finish, that's it. You save your data and you can destroy that virtual machine, and you're just paying for what you are using. You are renting those capabilities. You're not buying them upfront and spending a lot of money. So that's what gives you kind of flexibility from compute power to start with. Other things that I can think of from student perspective is, hopefully you're going to finish your degree, you're going to start working. Sometimes you need to learn something like Hadoop, for example. Hadoop, to create a cluster of Hadoop, it's first of all, it's very, very involved. Or Kubernetes, for example. There is so much you need to do. It's very expensive, first of all, to create a cluster itself. It does take time. It requires a lot of knowledge. So you need a lot of investment in place. So before the cloud, in order to learn Kubernetes, for example, or in order to learn things like Hadoop, in order to learn machine learning at scale, for example, you need to work for a very famous company that they've got those capabilities. Otherwise, you would just be learning the theory. Now, everybody is at the same level. So whether you are working for Microsoft or you are working for a company in your city, they both have the same access to the same capabilities through different platform. Obviously, we're going to do that for a study jam. We're going to get free quick labs access, so we can leverage that and things like that. So this kind of the advantages of cloud computing from the perspective of so you can upskill very, very quickly. So you don't have to wait and go to the job market without no kind of hands-on skills. So cloud gives you that capability to get the skills before you go to apply for jobs, for example. So it opens a lot of avenues for you. What are the different methods for the authentication of Google Compute Engine API? So there are a few. Obviously, the basic one, username, password. There is a service called Identity and Access Proxy, which does authentication and authorization of users. So you can set the cloud IAP. Let's say you've got multiple applications running in Google Cloud, and you decide who have access to this application. So you can configure that. The user, when they have an identity, the cloud IAP will decide do you have authorized or not. So that's one of the, and you've got like Open ID, you've got two-factor authentication in there. So many authentication, not just to compute engine, but to applications, Kubernetes clusters and things. I read before about eucalyptus and I didn't get well. What is the context? Eucalyptus. Where did you read about that? That doesn't ring the bell for me. It's probably some kind of. I need to look it up. Sorry. Don't get hung in something that doesn't make a difference for you to learn something new. But eucalyptus. Let me see. Eucalyptus cloud. Oh, okay. It says here it's an open source computer software for building. Okay. Okay, it's like a service, like what we've seen earlier in when I mentioned App Engine, for example, as a deployment, a service where you can deploy code. This is another one that is a software that allow you to build AWS cloud. So instead of going to the console, you can use this software to talk to AWS and create resources for you. That's all it is. If that's what you are referring to. Anything else? All right, we are 5 minutes over. So thank you for being with us today, and thank you for the invite. It has been a pleasure.
Thank you so much, Doctor. Thank you so much. It was a helpful session. Thank you so much.
You're very welcome, and we'll see you tomorrow with
Yes.
practical labs,
Google
inshallah.
Meet. Yes. Inshallah. Yes. In the same time, we'll send you the link, Google Meet link. Tomorrow's session will be so helpful to learn more about Google Cloud, and using Quick Labs is so easy and fun. So, inshallah, you will learn more about it. Thank you so much again, Doctor.
All right,
We'll
thank you. It's been a pleasure. See you tomorrow. Have a nice evening. Assalamu alaikum.
Wa alaikum assalam. Good night.